And clearly, the interaction between system, mold, part, process, alloy becomes a lot more important. Again, if you cast a small part, somehow you get there, somehow you might change also as the alloy or so. But at least what we observe right now in the projects we are executing, for megacasting, you have to have an early on very close alignment exchange among the various partners, the operator, die builder, the supplier of the alloy, the machine builder, the integrator of the cell. It takes a lot more intense interaction and alignment between these players than what we've seen before in the manufacturing of smaller or the production of smaller components.
Welcome to the exciting new episode of the Goldcasting Podcast. This is the podcast where we show you how to turn your aluminium into gold. And we have another series of our gigacasting episodes. It would be foolish to have a gigacasting episode without talking to Bühler. And now we scale it up to the megacastings. And we're super happy to have Dr. Markus Hofer with us from Bühler. Welcome, Markus.
Morning, guys.
We all know you as the business development wizard of Bühler. Maybe not always in the forefront, but controlling things behind the curtains. But as we know you, I don't think everybody knows you. So could you please introduce yourself, Markus?
Yeah, I'm a mechanical engineer by training. I'm working with the Bühler organization since many years in a number of different roles. I run 2 global businesses for a long time. And that probably gives me some credibility with the people I work today, the 3 non-food business areas within the Bühler Group, in strategy and business development. And of the 3 businesses, obviously, the die casting business is the biggest, most successful, and actually in a very exciting time today.
Why is it that exciting today?
Because we had obviously a quite difficult future a few years back when the writing was on the wall that internal combustion engines will not be the future, and that composed most of the business of the die casting business area. And for a bit of time, we were really considering what's next. How do we go on? Casting of structural parts was on the market for some time, but did not really take off in volume. And right now we see a lot of that coming at pretty high speed, and actually, I would say even on a global base.
Interesting. And how did you came up to say, okay, now we start to design 8,400, 9,200 ton machines to go with that race of clamping force?
I mean, typically these decisions are not taken lightly. Actually, we did a number of rounds internally. You always have the advocates of going ahead, and the guys are saying, "Yeah, we need to be a bit more careful," especially in a time when the future is not so bright. But I guess that's also beauty of being part of a family-owned private organization, that the owners also supported and say we need to invest also in times that are not so bright. We saw signs in the market, we saw interesting inquiries, and that basically brought us to the decision to start the development and to pull it through in a relatively short time.
You did this development of your big machine series extremely fast, or did we miss something? Did you start before and then develop for a few years, and then it looked like you did it super fast?
No, I guess, I mean, the period it was kind of public, or it was obvious, was relatively short, but we all know that there's typically a foreplay to that. And actually, I would say 2 factors. The one is we have a range of machines called Fusion, which was basically for us a game changer, not from what concerns the machine or the size of the machine or so, but the way we tackle things, the way we develop systems, the way we work with partners in development and supply chain. And that is also a bit of a cultural change, and that takes time. But once this was in place, actually we had all the tools to do it in a relatively short time. And I guess the second thing was we obviously did a lot of simulation and preparation work, just also to prepare the decision to go for the big machine. So I would say the basics basically were there, and then the execution of it was, admittingly in a relatively short time. Also, pull from the market was there. I mean, it was not that it was like an early harvest and we tried to sell it. We also saw quite a bit of pull from the market.
Speaking about this market pull, I mean, it looks like a race. I almost said something ugly about measurement here, but we see the machine sizes just going up and up and up and up. And now people are dreaming about 20,000 and casting the whole car in one shot. What is your feeling about the future? If you would, I mean, difficult, but if you need to guess or outline some vision about this subject, gigacasting, where will it end?
I mean, I guess all I'm saying here is also my private view. It's not a statement for the organization. I believe the limitation will not be the size of machine that can be built. The limitation will be the overall system, if I may say so, from feeding to handling to up and downstream logistics. And I guess we can also learn from other industries. I mean, if you look at the airline industry, it was bigger and bigger and bigger until, obviously, for some practical considerations, we said, there is space for that, but is it the bulk of all systems that will be built? Probably not. Frankly, I believe it will take still a few more years to fully benefit from the current range of 6, 9, 12,000 ton machines. There will be bigger machines, I'm sure, but frankly, I believe that will rather be the exception than the mainstream. Also, we see there are some interesting signs from the market where leading players say, perhaps we should not do everything in just one big shot. So I guess that might be an observation which underlines a bit that the very big machines might be rather an exception than the standard in the industry.
But do you see a change in customer behavior? I mean, in the old days, you could buy a tool and you called Bühler Utzwiller, you bought a nice DC machine and you bought a alloy from a well-known alloy producer, and then with some blood, sweat, and tears, you actually pulled off a shock tower or whatever you wanted to cast. But we hear from the market that getting the yield up, getting the properties out in all corners of this big casting is actually very challenging. Do you think the industry needs to meet these challenges to actually produce very big, very sound castings by working differently?
Yeah, I mean, first of all, everyone is on a learning curve. You guys, they claim they do it since some time, but overall, the industry is on a learning curve. We will see substantial changes in the industry because the bar goes up. I mean, it's getting more and more complicated. And if you cast a small part and your yield is so, that might be not nice, but you can somehow compensate it for it, a shorter cycle time or so. But if you cast these very big structural parts and you're basically very close to the assembly line, then this gets more demanding, especially getting to a high yield, and the required quality is challenging. And that probably limits a bit the number of players that can really do it successfully. So overall, I believe big structural parts will be handled by a smaller group of producers than what the casting industry has seen in the past. And also, you can probably not just simply switch your supplier and say, "I'm not happy with your price. I go somewhere else." But that's also, I think, we can also here learn from other industries. I mean, if you look, for example, at complicated processes like in semiconductor industry, that's also a chance to build better partnerships than we have probably seen in the past, where we had a food chain where the big guys were just squeezing the small guys. So frankly, I believe it could lead to a more fair industry behavior overall.
But if you look at the semiconductor industry, I actually made a few years in that industry. if you compare them to what we try to establish here as a discussion platform, the mergers of the disciplines, they are far more advanced. If you look in a semiconductor factory, for example, I mean, the integration between the different suppliers of different equipment is super deep. They're developing for years and years and years together, and then they start to sell the machinery. Like, it could be in 10 years. Do you see the same thing happening around the gigacastings, that we need some sort of a merger of disciplines looking a little bit like the semiconductor industry to get the yield up? Because, I mean, that's the biggest problem right now.
I guess it will come, but I don't see signs or encouraging signs right now. And frankly, it starts with a few simple things, like, for example, standardization. If you look at these huge molds, these huge dies, and everyone has a different pitch for fixation, a different interface for cooling, and all that. That will not help with cost, will not help with interchangeability. And again, if you look at the semi industry, there's a strong competition, but they managed to standardize on a few things. For example, substrate size. Okay, that's probably not true for die casting, but many other things like software structures, like interfaces, and so on. They managed to do that, and I think this is a prerequisite to do more automation, to link closer the various steps in the process. And clearly, the interaction between system, mold, part, process, alloy becomes a lot more important. Again, if you cast a small part, somehow you get there, somehow you might change also perhaps the alloy or so, but at least what we observe right now in the projects we are executing, for megacasting, you have to have an early on very close alignment exchange among the various partners, the operator, die builder, the supplier of the alloy, the machine builder, the integrator of the cell. It takes a lot more intense interaction and alignment between these players than what we've seen before in the manufacturing of smaller, or the production of smaller components.
Is that a factor because the machines are way bigger, or is it that many OEMs that start with the megacasting trend just starting up and haven't had a foundry before? So is there a different approach to the customers in comparison to the existing foundries doing structural castings and these new players?
I guess there are technological perspective. There's a technological perspective to that, but also clearly a supply chain or a business system perspective. On the technological side, I would say if you shoot 2 kilograms or if you shoot 200 kilograms, that's a completely different animal. And I would say we are not there as an industry. I mean, we can do it, but there's still a way to go to make it really a robust, highly efficient process. And the second thing is really what you say, Fabian, is we see new players. They're possibly used to different division of work. You know, if you build in steel, typically you get a complete system, including coil, unreeling, and everything. And that part of the industry, I guess, still is in an early phase of the learning curve concerning the material handling, the production process. But actually, it starts a lot earlier. It starts with design of the part. And from what we observe, there are some players that have a good expertise there. Others are in an early phase, and you know much better than I do that a successful die casting process actually starts with the design of the part.
Yeah, and especially in that case, just changing an insert is a major operation. It's not like just sending a small package with an insert. That's a huge truckload, and you have to go to every municipality to get the permits to transport it.
But I also have to say, I believe this is a huge opportunity for the industry, because for that part of the business, we see, and I'm referring to OEMs getting into a lot more into die casting, because the design authority, part design authority, and the production is in one hand, which in the past, was always a bit of a challenge. Someone did the design and the specification, and someone else had to produce it. And changes were difficult process or are a difficult process. And I believe midterm, this is a very good chance to very tightly link part design, understanding of the process and production, and that will ultimately lead to better parts, higher yield, lower cost.
So you're pointing at something very interesting. To pull these mega projects off, I mean, you kind of need to have the decision power very centered. Decision power when it comes to everything from design, investment, what people to employ, etc., etc. And the second thing is that you have to be in a more iterative design process, I guess, where the old business model doesn't apply very well. Is that how I should interpret what you just said?
I mean, I've a limited view here, but the few things I see is, of course, we have early adopters, guys that say, we do it. The more traditional part of the industry, there I believe those players are moving faster, where we find champions in the organization that say, yes, it's a learning curve, it's an initial investment, it's a change of what we do today, but on the mid and long term, it gives us huge benefits. And I think it's a lot more than a new production technology or a different material to build a body in white or parts of a body in white. I believe it will be a huge cultural change in those organizations, but that will bring long-term also a huge benefit. And I mean, we see today guys that work in this new, different way. They are, at least for the time being, hugely successful. I mean, they build very nice market shares with good products. But if the main thing behind is that their culture, their approach is different. It's perhaps we might even compare it to software generation. It's you don't build it for 5 million units. You build it for the next lot of that could be 100,000 or so. Then you go to the next. I'm not saying it's already fully optimized and mature, but it's probably the direction to go.
I had a bit different takeaway from what you said, especially as all these new OEMs that didn't have much to do with the foundry industry start producing their own cars with Megacastings. Is there also a new age to develop more castings in the car instead of going for stamping or welded constructions, as they get now the knowledge with casting and see the advantages?
Yeah, I guess the better you know your tool and you more comfortable you get with it, the more obviously you try to apply the benefits of the process. And I guess the industry is aware. We engaged in Comtech, Bühler, as an organization. And the reason behind is that we believe that with better process technology, and we consider rail casting as part of that, the range of parts that can be economically produced will be substantially extended. That is basically what you're asking, I guess, is also the background of our engagement in Comtech.
But do you see other fields also besides the semi-solid? I mean, you as Bühler, are you adapting also with more metallurgy, more tool building competence? Do you see a change there to be successful selling machines that you need to offer more than just a machine, if I put it that way?
Yeah, I guess this depends a bit on what role you want to play in the industry. And I guess as Bühler, we try to be a major partner to our customers, but also a shaper of the industry. And we see that we need to extend our network, our partnership, also in materials, in die design, die building, in application support. But I believe it will not happen in a classic way, that these activities are required and integrated. I guess the new world is more a network approach. So that, for example, we as Bühler, we bring customers and good die builders together and hope to support that with some process know-how and interface understanding of interfaces. But clearly, integration will go on. You mentioned in the past you bought a machine and a die and some peripherals, and you called an alloy supplier and you're there. And some of that will continue, clearly. But that is probably the commoditized part of the industry. I'm not sure whether at Bühler we will be a leading player there, but what our ambition is really to be at the forefront of development, not just concerning technology, but also the production and supply chain of it. And from that perspective, also the role of materials and what is strongly linked to that are all the sustainability considerations will become more and more important. And we have to understand this, build a network, but what we most probably will not do is directly engage in this.
Sustainability is interesting. I mean, we work deeply with that. And the first guys to jump the train and being very successful is actually medical equipment manufacturers. They represent maybe 0.2 promille of the die casting industry. Second wave that we're in the midst of is the telecom guys. Deeply afraid of the CBAM, having huge amounts of aluminum, coal-based Asian. The car industry is talking, but I don't see much of an effort to actually be creating more sustainable castings. Do you think we will see a brutal waking up, or will they just manage by other means to avoid taxation, carbon dioxide, import taxes, all the things that we're under the umbrella of sustainable casting, sustainability?
I mean, first of all, and then now I sound like a hard-nosed business guy, but things need to be financed somehow. And I guess we can see in the food industry, yes, there is a market for organic, sustainably produced food, but it's not the bulk. I mean, in the end, people need to be able to afford what they buy. And frankly, I believe we will see probably a similar situation in the car industry. And some people might throw stones at me if I say a car is a consumer good, but in the end, it is a consumer good. It's you buy it with certain emotions, and regulations will play a certain role. But more important, I believe, is customer attitude. You know, if people are more concerned about the footprint they leave with their behavior and the things they buy and use, and obviously car is an important consideration of that. Now, what I struggle a bit, and that is why I'm a bit skeptical that things will move fast, is, I mean, if you look at the average rates of cars, especially with also with battery electric vehicles, that goes only in one direction, that's up. I mean, in the probably 30 years, 20 years back, we had 1,000 kilograms of car to carry 80 kilograms of driver. Now we are rather at 2,000 kilograms of car carrying 80 kilograms of driver. And everyone still believes, or general understanding is that yes, battery electric vehicles are green and nice and kind to nature, which is probably not completely true. So unless we really find a more general understanding that mobility needs to become leaner, I believe the pressure will not be that big. So probably shorter term we see regulation impact during this, but perhaps longer term also consumer attitude and consumer expectation and consumer concerns will play a role in that.
Oh, you're into a minefield in this pod, you know, because you have the diesel-loving Staffan Zetterström in one corner, and the other corner we have Fabian Niklas, proud owner of a Tesla. So I absolutely agree with you, Markus, because I think you see the setback in sales in the US on the electrical vehicles. Another interesting point. A friend of mine is a car sales guy here. They sell hundreds and hundreds and hundreds of Teslas every week, other brands too. Please forgive me. And he says he's have more and more concerned customers, not due to image or anything. It's about the second-hand market. Because now you see news about solid-state batteries going 1,100 kilometers in one charge. What will it make to the second-hand value of my car? So if I buy a vehicle now for, I don't know, 80, 90,000 euros, they are pretty expensive. Expensive cars. And what happens if NIO or BYD or Tesla, whoever, comes up with something. Because this is the scary thing. In the old days, you had Volvo, you had BMW, you had Daimler. We knew them. All news was incremental, stepwise, small. A little bit heavier car, a little bit more horsepower, right? Better infotainment.
Yeah, but also I would like to add that in those days, you bought the car and drove it until you put it into the scrapyard, and then you got the next one. Not like it's now that you more often change your car.
Yeah. And then in combination with a younger generation that, but by some reason, don't want to own their own car. I got 3 boys, 26, 23, and 19. Only 1 out of 3 is interested in having a car, and that's the youngest one. So if I buy a car for 90,000 euros, and then Tesla, BYD, Daimler, whoever starts to throw around semi-solid batteries in a few years, going the double range, and it's much easier, lighter, it's a better car, basically. So the technical development is that fast. So no one is certain about second-hand market or the value of your investment because someone has to invest it.
But and that is probably the limit of my picture of the car being a consumer good. Because obviously we used in mobile devices and so on that every 3 years or so we get a new one, and it's double the performance of what we had before. That most probably will not happen with cars because there's always a physical system behind, and of course I can do better chips and so, but the physical system, the weight, the speed, and all that is still will remain. An interesting notion is if you look at the car rental companies, I think their enthusiasm is somewhat reduced concerning EVs. And some guys even are claiming, their business model is disrupted because part of their business model is selling cars after a certain use period. And obviously that revenue is part of their total revenue. And with the performance changing and the remaining value of the cars changing substantially, their model is a bit at risk. But I believe that is part of, I would say, if you allow the term, it's still a relatively immature situation. Sticking to your picture of young people not buying cars, but rather using them when they need it, I think that will lead. We've seen a first wave of mobility service companies making cars or scooters or whatever available. Not many of them have been successful, but I'm convinced that in the next iteration, next round, we will see fewer of them, more successful, and addressing exactly that need. That people want to drive one type of car one day and another type the next day, and make this available. And that will cover part of the market. For the old guys like me, probably they buy a car and they keep it for 5, 6, 7, 8 years. And yes, then perhaps I get a more performing car, but I would not drop my old car just because there's a car that can now do 1,000 kilometers and the current model only does 500. But I don't think that will happen. For that, the purchase price or the investment is still relatively high for a consumer good, if I may say so.
Yeah.
Also, if you compare the cars now, the electric vehicles, they are really fun to drive, and the range is not too bad. For someone comparing, okay, I'm sitting in my car, I have a diesel engine, and I can drive 800 kilometers in one sitting at 160 kilometers per hour. That's probably not the car for them. But I understand also, for me, I drive the electric car every day. But renting an electric car in a region where you don't know where you can charge, how is the charging infrastructure, which apps do I need? That's a bit complicated. That's also something, if I'm traveling somewhere, I need a rental car. I don't want to do that research. I just want to sit in the car, drive it. That's something I can do with my Tesla. And with the other ones, I have to check which app is there, which stations are included, for which apps do I have to download to charge somewhere. And then it doesn't really work with the app. So that's really a hassle that there's not like with the gas stations. You go there, put in the nozzle, pump the gas, pay by card, and leave. Why does the EV industry doesn't get that system, why do you need an app to put a credit card in?
I absolutely agree with you. And the thing is, if I were to just be here in Täby, north of Stockholm, maybe occasionally go to Arlanda to fly down to Utsville, to my colleagues at the Bühler, that will be one thing. But Sweden and waste areas of the US, for example, are rural. It's a cornfield, in Midwest, for example. And for me, going up north 5-6 times, or many people in Sweden, there is actually no infrastructure. And how to finance that infrastructure? I know that we're a socialist country, but even they cannot make this happen in that short time.
No, Staffan, I think even the most optimistic guys is at 50% EVs. And so that means we have another 50% of ICEs. Yeah. And I think that's a reality that we use the car or the type of car or mobility pod according to our needs. So, for example, at my home, we have 2 cars, so a slightly bigger one and a slightly smaller one. And it's clear the slightly smaller one will be a EV because you use it for commuting to city, to shopping and visiting grandma and so on. But if we take a trip to southern Switzerland, obviously we take the bigger ICE car, and exactly what Fabian mentioned. No hassle about where to charge and all. I understand it's turning aluminum into gold, and we should keep this in mind when we look at the further development of structural casting, because especially in China, we see that the supply chain and the way cars or mobility pods are built is somewhat different than what we're used to in the Western world, if I may say so, or not even, I would say, in the traditional car industry. Because you have heavy production assets to build cars. If you look now, especially in China, you don't have to have it. You have to have a brand. You have to be able to do an extensive suite of software. And then basically you find everything. You find components, you find people to produce your parts, to build your car and all that. And we see loads and loads and loads of new brands, new ventures coming up. And it will be interesting to see how many of them will really be successful. Because if you look back in China, if you look at photovoltaics, if you look at battery industry, battery cell industry, if you look at display, and a number of other activities, it was always the same pattern. We had many in the beginning, and then the survival of the fittest, whatever fit means in that context. And
there's actually a guy made research.
I mean, quite a bit of the investment you observe right now in structural is not yet the traditional car builders, OEMs, and their supply chains. It's these new platforms. And there is possibly a bit of a risk that we will end up in a few years with overcapacity, because not everyone will make it. And so we enjoy a good business right now with investments into structural parts, but we would frankly love to see more of the traditional car industry jumping on that wagon faster than what they are doing right now. Of course, we have a few substantial OEMs going down that road, but it's not yet industry mainstream, if I may say so.
But we can conclude one thing. It is happy days in die casting if you are an engineer, I think. I mean, have we ever seen this much investments in die casting machines, expensive toolings, development of alloys? I mean, it's a new horizon. On the flip side, not sure that I would invest in a smaller family-owned die casting shop somewhere in Europe.
Unless they really have a very good niche. I mean, there are always good niches.
Yeah,
especially what we see with the EVs, that most of them are on a greenfield production. You can scale up the part size, have a lot of part integrations. Doesn't need to be that mega casting. You also see that you can split that into 4,400 ton casted pieces. How do you see that impact, especially if you consider long-term 50% of ICE cars? There is no harm getting them as well with the gigacasting. What's your take on that?
I guess we always said that structural parts and megacasting are not strictly linked to EV platforms. But the reality is, of course, new platforms right now are predominantly EV platforms, and that's why we see most of the investment going into this. But I fully agree. We will see for future IC platforms, and there will be, I'm convinced there will be. We also see an increasing content of structural parts there. Perhaps just one remark to what we discussed just a minute ago. We need to make sure that the industry doesn't end up in a hangover like the PV industry a few years back. That we have a huge wave, a huge amount of excitement, huge investments, huge subsidies, and then almost overnight that died away and created actually a lot of harm and a lot of wasted investments. And so from that perspective, I think, again, the size of the consumer good car is a good thing because it's a lot more complicated, a lot more expensive than a PV module. And so the start of production of new platforms actually will meter a bit the amount of die casting investments that are needed. And again, we probably see a difference between the China domestic market and the rest of the world. I would say the metering is better in the rest of the world than it is in China.
I think we will see in 1978 again, when I was a young guy. I come from a small town, with a lot of traditional factories and steel making. And I remember one of my first rememberings in this life was that I heard that now people from Poland and Japan will take all our dad's jobs. It was the oil crisis, basically. And the interesting thing is that we saw these yellow Datsun from Japan. It was a Japanese car. It started to rust in 2 years and everybody was bullshitting about them. Look at Toyota today. Things evolve. And I think we'll see the same thing. And the easiest way to see it is actually the sales of roll-on, roll-off ships. Mm-hmm. Normally, 6-7 a year ordered. Now it was 26 in 2022. In 2023, I think it was 24. Mm-hmm. So someone was buying 50 ships instead of 15. So a tripling or a quadrupling of that capacity. And of course, they are sold to China. So we will see 1978 again, but instead of yellow Datsuns, it will be a Chinese brand, and we will laugh, old guys like me, born in the 70s. And then after a couple of years, we'll say, not a bad car, let's buy it.
Yeah, don't get me wrong. I'm not laughing at all. I'm just saying after a few hundred that are existing now, a handful will probably be successful. And actually, the guys that have a better, longer plan, they have quality, they have good cars, good supply chain. I think these guys will survive, and they will find customers in Europe, in the US, with or without taxes and subsidies and all that. Because that's an interesting thing. On one side, the producers get subsidies, and they are kind of offset by import taxes on the other end. So
it's a balance. But we're forgetting one thing here. If you take the ICE platform, 80-90% of the consumer feeling is actually the software. In the old days when we were young, I had hair and stuff, developing a better car was something about the drivetrain, the engine, the brakes, and the steering system and the mechanics. It took 1, 2, 3, 4 years to actually correct it. Today, they download a new software version while you're sleeping. So what I'm saying is the time to go from a product where with the yellow Datsun is 1978 to something everybody wants to have in an electrical vehicle could be done in 1 year. In the old days, it was 5-10 years. So it's much faster, the development of the car.
Yeah, I agree for the software side. Mm-hmm. But again, there's also a physical system behind. Mm-hmm. And that there, I guess the development times are a bit low.
I beg the difference. If you take the software for controlling the drivetrain, for example, I mean, the power curve of an electrical engine is just a straight line. Adapting that one, adjusting it, same thing with the brakes, you use the electrical engine, so the braking system. If you look at a Ford, for example, I saw the CEO of a Ford was ranting around this, that they are paying huge amounts per car. They got 120 softwares. So trying to change something, they had to call Bosch, for example, and then, no guarantees apply, blah, blah, blah. So having a central software is actually one of the keys to developing cars and adapting the car in the street. Mm-hmm. Having said that, an ICE has more advanced softwares to reach the same effect as an electrical vehicle, because an electrical vehicle is much easier to control physically. So I think we have to watch up here. It will be fast, the development of very high quality cars.
Yeah,
it will be fast.
I did, Stefan, I guess I did not say it's not fast. I just say software changes are faster than changes on a physical system.
Yep.
Yeah, but I think also that software will lead to the buying decision of the producers, as that's the main direction. If you're sitting in an EV, there is no fascination about the sound, how the electric motor sounds. It's more or less how the usability is, like,
Yeah. I mean, take a motorcycle, for example. You have a nice juicy Yamaha that drinks gasoline. It will be like horses, in the future, I will have to take it to a certain track where I can drive around a little bit like a horse today, and then I put it back in the garage, and then I take my EV to work.
Yeah, but that
will happen.
Then it's more your leisure time.
Yeah, exactly. It will be like a horse.
Yeah. Oh.
Yeah. So if you were restarting your career in the die casting industry as of today, Markus, and you meet yourself being 25 years old with a university degree in your hand, looking at the bright future in the die casting industry, what kind of advice would you give yourself?
I would pick a place where I feel I get projects and the responsibility and a thing to work on where I can test myself and develop myself. Now, saying this is probably not so easy to find, because typically that's easier to achieve in a smaller place than in a bigger organization. But actually starting directly from university, I would probably still go to a place where things are done professionally. And I'm not saying small organizations are not professional, but I'm saying in a bigger organization, there's a chance to find pros in many different aspects. We talked about merging of faculties and merging of expertise, be it material, be it testing, be it production, be it supply chain. And frankly, you bring from university, you bring a backpack which is predominantly theoretical, and I would really try to complement that. My first job would be in a place where I feel, yes, it's a professional environment, and I get a project or something to prove. And I mean, pay is pay, but that would not be a priority for me. But because if you prove yourself successful in executing projects and achieving things, then the pay thing will automatically adjust and develop. So I would really pick a good professional environment and understanding that it's typically not for life, but you could spend a few years there, or you probably could build also a career there. But it's an exciting industry. It's a place where you don't only sit in front of screens, but you also see things happening in real. You see parts being made. If you're not a software nerd, then I believe it's a very, very nice, very exciting industry. And there's a saying, it's difficult, dangerous, and dirty. But if you go to new sites, and that might be true for some of the very old places, if you go to new sites, I mean, that's just impressive, fantastic production facilities with a lot of high tech from the beginning to the complete end. Great industry. Someone with a mechanical or materials background, I think it's a very nice industry.
Return of the metallurgist.
Yeah, I mean, it was never gone. Let's face it. But also, railcasting probably helps to get more out of a material. And I remember, the times when BMW came up with their very nice i3 car with loads of fiber composite and all that.
Yes.
Probably many heads were scratched in the industry saying, okay, did we miss something, and what happens here? And I guess now 20, 30 years later, we see you can always find an additional benefit in in a technology, in a material that we know very well. Especially in die casting, we should also observe carefully what the steel industry is doing, because these guys are not dumb. These guys can also build nice structures, and I believe the sound competition between the material systems will continue. Right now, we have a good chance also to build and extend the position of aluminum and die casting in the industry.
Yeah. Steel is strong, and no one is giving up without a fight. So I absolutely believe with you that we need that competition between the ideas to develop the ideas, because otherwise everybody will buy a 9,000-ton machine, and we'll end up where you were discussing just a few minutes ago, with an overcapacity and no people to run it, and it will be a big failure. So let's hope for competition.
But still, having that machine on your premises as a car maker is a strong mode to continue using them, as the investment is already done and it's already decided by the C-level suite of the automaker.
Fully agree, because the steel guys have been on site. We've been in tier 1, tier 2, tier 3. And now we have obviously with a few exceptions, but obviously now we have a good chance to get on site with die casting and aluminum. And I think we should do our best to make this happen and to stay.
I think that's a perfect ending for that podcast episode, and a strong advocate for the megacasting trend and high-pressure die casting industry overall. Thank you all for listening in. Don't forget to subscribe, and then we'll see us in the next Gold Nugget. Until then, goodbye.
Thank you very much.
Sayonara.
Thank you.
Thank you. Bye.